The following question was asked from the concept of function and it was asked for 1 mark. The question is as follows. Let f a real number to real number be a function such that function is having definition like max of x to x cube, where x belongs to the set of real numbers and set of all points where fx is not differentiable is right. So what we need to do, we need to just have a build up the function. So our function look like fx equal to, so if it is x and one more is x cube, so if x is lesser than or equal to 1 or x is lesser than 0 and greater than -1 and one more x is having lesser than equal to 1 or greater than equal to 0 and x cube where x can be greater than 1. So clearly the information, if you can see that it is a continuous at every real x, it is continuous at every real x. And when it comes to differentiation, when it comes to the differentiability, this will become 1, this will become a 3x square, this part will become 1 and this part will also become 3x square on the same rule, right? So at x equal to -1, f dash of -1 plus equal to 3 into -1 ka square, that is 3, correct? Now if we are going to put f dash of -1 minus, it is equal to 1. So here if you will see, LHS is not equal to RHS. It means that it is not differentiable at 1. It is not differentiable at -1. So if it is not differentiable at -1, if it is not differentiable at -1, it should be mentioned in the option, which is not in the option C. So it is cancelled because it is not mentioned here, right? Further, if you will do it with 0, if you will do it with the 0, then again you will not get LHS and RHS equally. And if you will do the differentiability with 1 also, then in that case also LHS and RHS will not be equal. We only need to put the value of 0 here. So in that case also we are not going to get the same. Thus -1, 0 and 1, at this particular points our function is not going to differentiable. So -1, 0 and 1, it is mentioned in option D. So option D is the correct answer for this GATE question. I hope it is clear. The following question was asked from matrix and the question was asked for 1 mark. The question is the product of all eigenvalue of the matrix which is given is. So here we need to be very much carefully look on the matrix. It is like that: 1 2 3 4 5 6 7 8 9, and this matrix is very famous matrix, and you can say that the linear dependent is there, linearly dependent is there. How? So let's say if we are going to see here, if you are going to just see here the columns, right? 1 2 and 3, then this particular column or this particular column or this particular column, let's say it is a C1, C2 and a C3, then there is a relationship between C3, C2 and C1, that C3 is equal to 2 into C2 minus C1. For example, what is in C3? You are having 3 here, so 3 equal to 2 into 2, that is 4 minus 1, that is 3. So there is a linear dependence between column 3 and column 2 and column 1. So whenever you know the rule is there that whenever we are having linear dependency in our matrix, in that case the determinant is 0. Thus the product of all eigenvalue will be 0. So using the simple rule, if we are having any linear dependency in the matrix, So this is the linear dependency in our matrix, and due to the rule that if we are having any linear dependency, the determinant is 0, and the determinant is 0 means all eigenvalue will be 0, product of all eigenvalue will be 0. The option B is the correct answer for this gate question. The following question is as follows: consider a permutation sampled uniformly at random from the set of all permutations of 1 to n for some n greater than or equal to 4. Let x be the event that 1 occur before 2 in the permutation, and y is the event that 3 occur before 4. Which one of the following statement is true? So the event x and y are mutually exclusive, or the event x and y are independent. Either event x or y must occur. Event x is more likely than event y. So in this case, total number of we are having the value of px, that is equal to py, and that is 0.5, and p of x comma y, p of x comma y, if you will see, then occurs before 2 and y occurs before 3, right? So 0.2555, and that is nothing but probability of x into probability of y, right? So total number of permutations will be n factorial. So number of permutation when n, if n equal to 1, let's say, so when 1 come before 2, means this part we are covering, when 1 occur before 2, so it is nothing but nc2 into n minus 2 ka factorial, right? So I can say nc2, just we can write it like n2 into n minus 2 ka factorial, and number of permutation where 3 comes before y. Here it is 1 coming before 1 before 2, that is this part, and 3 occur before y, that is also n 2 into n minus 2 ka factorial. So number of permutation where 1 come before 2 and 3 come before 4 is nothing but n2 into n minus 2 into n minus 4 ka factorial. So the thing is that if you will try to map here, occurring of any of the event will basically not affect occurring of any other event. In that case, we can say that event x and y are independent. So option B is the correct answer for this, which was asked for 1 mark. B is the correct answer. I hope it is clear. The following question was asked from function, and it was asked for 1 mark. Let A and B be non-empty finite sets such that there exist one-to-one and onto functions from A to B and from A cross A to A union B. The number of possible value of absolute A is, right? So you know that there exists one-to-one and onto function, one-to-one and onto function between x and y. So this implies x equal to y, right? Because one-to-one and onto function is there. Hence, what we can say, that what we can conclude from here, that a will also equal to b, and that will lead to the result that if I am going to write a square, I can write it either a plus b, because both are equal, right? Minus a intersection b. So the number of possible value of a is, the number of possible value of a is, so we need to check manually. So can a is 1, so if you will just put here then 1 will be followed, 1 plus 1 2 minus 1, so it is followed. So 1 is one of the possible value. Can mod of A is 2, so 2 plus 2 4 minus 2, it is also 2, it is also followed. Can A be 3? 3 plus 3 6, but in that case if you will see in the term of intersection it might be the odd value, because for larger value the a square is there, right? A square is there, it should be greater than a plus b, because there is a relationship of square. But here a square, that is 9 in the case of 3, right? That should be greater than 3 plus 3, yes, but they are not equal now. Right? 9 is greater than 6. Thus only two values are possible, that is it could be 1 or it could be 2. So the answer will be 2. It was a NAT based question, so answer will be 2. So I hope it is clear. The following question was asked from spanning tree and graph theory. The question is as follows: the number of spanning tree in a complete graph of 4 vertices labeled A, B, C and D is. So it was asked for 1 mark and the nature of question is NAT, numerical answer type. So directly formula based question it is. Number of spanning tree in a complete graph or 4 vertices. So you know the 4 vertices are like this. Let's say the 4 vertices are A, B, C, D, and if it is a complete graph, each and every vertex connect with each other. Correct? So this is a 4 vertices graph which is a complete graph, and there is a formula that whenever we have a complete graph, whenever we are having a complete graph, then the total number of spanning tree is nothing but n की power n minus 2, where n is nothing but number of vertices. Just a substitute n 4 की power 4 minus 2, that is 4 की power 2, that is 16. Just a formula based question, that in any complete graph total number of possible spanning trees n into n की power n minus 2, where n is number of vertices. Thus 16 is the correct answer for this gate question. Very easy question. I hope it is clear. The following question was asked from graph theory, and inside that the topic is chromatic number of a graph, and it was asked for 2 mark. The question is as follows: the chromatic number of a graph is the minimum number of color which we use for a proper coloring of the graph, right? It is the basic definition of chromatic number. Let G be any graph with n vertices and chromatic number k. Which of the following statement is are always true? Correct? 4 statements are given, is are. So the nature of question may be MSQ for 2 mark. So let's scan one by one. Option A is G contain a complete subgraph with k vertices. So it is false. Why it is false? The reason is the chromatic number k does not necessarily mean that graph contain clique of k vertices. CLIQUE. Graph contain what? Clique of CLI. Clique of k vertices. It does not necessary. That is false. Option B, if you will see, G contain an independent set of size at least n by k. So this is supported by pigeonhole principle. One concept is there that is called as pigeonhole principle. Means if there are n plus 1 pigeons, and if you are having n number of pigeonholes, obviously one pigeon will be there which will not allocated the pigeonhole, because the restriction is that only one pigeon can be there in one pigeonhole. Using that principle, we can simply say that G contain an independent set of at least n by k. True. Option C, the minimum number G contains at least k into k minus 1 divided by 2 edges. So you know that minimum number of edges between k color classes is given by the combination of KC2 formula. KC2, that is nothing but k into k minus 1 divided by 2. So again, this is also true. And option D is G contains a vertex of degree at least k. So consider a cyclic graph of any odd number of vertices, right? So let's say if this is a cyclic graph which is having three vertices, which is the odd vertices, and although it's although you can say that it is a cyclic graph, and its chromatic number is 3. Its chromatic number is 3, but it does not necessary that every node will have 3 degree, because this node is not having 3 degree. This node is having 2 degree only. So it is not necessary anytime. Thus D is also false. So if you will see here, option B and option C is the correct answer. Option B and option C is the true statement for this. This is the correct answers, B and C. I hope it is clear. The following question was asked as a simple law type question from discrete mathematics for 2 mark, and the question is consider the operator, and this operator is given like a diamond shape, and this operator is given like a rectangular shape, defined by the few rule, and the rule is a diamond b equal to a plus 2b and a rectangle b equal to ab. For positive integers, which one of the following statement is are true? Operator diamond obeys associative law. Operator rectangle obeys associative law. Operator diamond over the operator rectangle obeys the distributive law. Or option D, operator rectangle over operator diamond obeys the distributive law. So we need to scan one by one in order to check them. So let's say if I am checking first one, operator diamond obeys associative law. So I need to write it like A diamond, B diamond, because they are operator which is given and rule is associated only, nothing else, equal to A plus 2B, and I need to make diamond here with C if they follow associative law. So it will be A plus 2B plus 2C and A diamond. If I will make diamond with C, means A, now this diamond is outside, and B diamond C equal to A diamond, and here if I am making B plus 2C, so this 2B and C is just inside the bracket. So what if it is A plus 2B plus 4C, using this rule. So you see here that if you consider this as a LHS, if you will consider this as a RHS, they are not equal. If they are not equal, means they are not following associative law. They are not following associative law. Option A is rejected. Option B obeys associative law. Okay, so let's check. So option B, for associative law, rectangular means I need to follow this. A rectangle, B rectangle with C equal to AB rectangle with C, that is ABC, and A rectangle B rectangle C equal to A rectangle with B and C. I am using this law, using this law. So it is also ABC. So here LHS is equal to RHS. That's what I can say. Yes, option B is following associative law. Operator rectangle, this particular operator, whatever this operator is, it is following associative law using this rule. So B is the true. True is ours, right? So B is true. But is R is there, so it might be MSQ in nature. So we need to scan option C as well as option D, right? So do the same. Option C. So if you are going to perform on option C, that operator diamond over operator rectangle obeys distributive law. So let's try to do this. A diamond B rectangle with C, operation diamond over rectangle, equal to A diamond B and rectangle A diamond C. That is option C it is saying, right? So if you will try to solve it, then A diamond B rectangle C, it is A diamond BC, and I can write it like A plus 2BC. And similarly, if I will do, this is for LHS I done. This is for LHS. Now I am performing for RHS. So if I will do with RHS, A diamond B rectangle A diamond C, it will be equal to, follow the same rule, A plus 2B rectangle or square, it could be A plus 2C. We only need to careful about the rule what they are saying. So if you will do it, it is A square plus 2AC plus 2AB plus 4BC. Obviously the RHS is something different, LHS is something different. RHS does not equal to LHS, thus option C is also rejected. So this C is also rejected, right? And only option D left now. So let's try to scan it. Operator rectangle over operator diamond obeys the distributive law. So let's try to scan it. So if you will scan it, A of rectangle B diamond C, if you will try to do this, it is A of rectangle B plus 2C equal to AB plus 2AC. And if you will do with the second part, that is A rectangle B diamond A rectangle C equal to AB, because this is multiplying, diamond AC. And if you will try to analyze it, it is also AB plus 2AC, because we are following the rule which is given in the question. With for this rectangle this, for this diamond this, for this rectangle this. And here if you will see, LHS is equal to RHS. So if it is so, means D is again true. D is again true. So out of this, AC rejected but D accepted. So option B and D are true. B and D are the correct answer for this question. I hope it is clear. You only need to derive by taking this equation, and you need to compare LHS and RHS, right? So B and D is the correct answer. I hope it is clear.